let's look at trying to do a Saturday to Sunday time frame forecast for West Virginia, in particular for Beckley area. If I'm doing a forecast, I need to know what's going on now. So what is happening right now? Well, one thing I see immediately is this one heck of a strong low, extratropical. Notice the occluded front up here, warm front through New England, cold front down through eastern part of West Virginia. Notice the temperatures behind this front. We're talking temperatures in the teens in the middle of the day, and even in the low to mid 30s all the way south to Iowa. And here's Kansas at 37. That, for this time of year, is extremely cold air. Looks like there's some kind of high sitting to the north of that as well. So right now, if I'm looking in West Virginia, I know initially I'm going to be cooling off. I have a front coming through. But how is this whole monstrosity of a low going to evolve over the next 24 to 48 hours, even 72 hours as it moves east? I'm seeing a weak low down here. Is that going to intensify and come up? Is this just going to drift to the northeast and weaken, which is quite likely? All of that is something I, as a forecaster right now, or you as the forecaster, would want to understand and know in the future. That's why so much of what we try to do, yes, we look at what's happening. And for the first 6 to 12 hours, what you see makes very good sense and can really help your forecast. But after that, you can take a peek back at what you see and see how it's changed and understand whether that may make sense climatologically now. Because sometimes the models do things that don't make sense. Oh yeah, we have a pretty nice high sitting off the east coast of the United States. The subtropical high that we've talked about. And temperatures in the 70s here. Matter of fact, at my house right now, it's 85 degrees. So, and we can look and see how this has changed. 12 hours ago, front was all the way back in western Indiana, and the low was up over South Dakota. Still extremely, extremely strong. And now the low's only made it to Minnesota, so this thing is not moving fast. The front is moving well out ahead of the low. One thing about that would say that the cold air that's coming around this is probably being modified by bare ground across here. So it's not going to be as cold as what's back here. So what is happening aloft? What's happening at 500 millibar? Well, amazingly, we have a very strong low at 500 millibar right here. Corresponds literally with the low that's here. When they get vertical like that, we know the low is not going to intensify anymore. But that is a extremely intense, for this time of year, low over Minnesota to North Dakota. So it's probably been tracking east with time as well. We could look at the same time and go back, if we want to, and pull up an 850 millibar chart at the same time. Why do I use an 850 millibar? Because I'm curious on temperatures. Temperatures are ridiculously cold right now up here. Minus 16, minus 13. And the 0 degrees is all the way down to right along this line right here. What does that mean? Well, if it's 0 degrees at 850, which is only 5,000 feet off the surface, and it's cold enough underneath that, you actually can get snow, even in this time of year, if that passes your location. Right now, a lot of warm air, a lot of moisture coming up. But that is a very impressive amount of cold air. And you can see, yes, the winds are turning more westerly, so maybe we're not going to get as much of that cold air, but we're definitely going to be cooling off. So, two things I've looked at so far on the forecast. I have an intense low that's probably pushing at the cold front east, but I'm going to modify that air as it's coming east because it's moving over bare ground. It's not snow covered down here, it's snow covered up here. Looking at GOES, you can see the intense low, but look at all this clear skies out here. You don't see any snow on the ground either. So it looks like it's going to be clearing off shortly in West Virginia. And we have this very nice looking low pressure here. Warm air coming up the East Coast. One of the things I'm curious on, and I sometimes can get mid-level moisture, can kind of show what is going on maybe over the whole pattern. It may pick out some upper level lows a little better, which it does right here. Has a jet streak right here and along like this. So it is showing some of what we've been talking about and picking out. Again, this is just utilizing the moisture channel to actually look kind of at where the winds might be coming from and the weather, the upper level pattern. So now that I've taken all of this in, let's move on to the models. Just trying to keep this simple. Numerical prediction is a way of life as far as making a forecast goes. Everything we've talked about can be translated into equations that we can't solve. So we approximate them. And we're getting better and better in our approximations. Oh yeah, and all that you saw where the front is, and the upper level winds are, all that is an approximation. We can still be off in some of that. So we start off with the approximation of what's currently happening, and then we apply approximations to the equations to solve them. So 2 times I'm messing with this forecast. So here's your 500 millibar low that we've looked at. So let's start moving this model. This is only, I'm only going 72 hours, so I'm not going far. And it's sure not moving very fast, is it? One thing I notice is that there's a very strong low up across northern Canada here that's completely separate from this system. And there's another low off of Greenland. So this low is having trouble figuring out where it's going to go. It looks like it actually wants to deepen in the eastern part of the United States. There may be kind of a Rossby wave right here, which would allow this low to deepen. And if it's deepening, that means it's probably going to bring in colder air in. So I just looked at 500 millibar right now. I'm going back because I want to look at 850 millibars and see the temperature. And I want to notice if there's any change in how the surface pattern looks. About 0 degrees being cold enough for snow. Well, here is the model coming along right here. And we don't see the 0 degrees coming into West Virginia, thank goodness. Through Friday anyways. But some more moisture riding up here. And there's even more cold air. This is a pretty cold high coming down right here. And we remember we saw it deepening. Well, all of a sudden we're -3 to even -6 in West Virginia at the end of this. No moisture really, thank goodness. But you're actually cold enough that you could have a few snowflakes if there were some. And with a little bit of a northwest wind into the mountains, maybe a few little flakes of snow would occur in the mountains, but probably not likely. So that we've looked at this now, we know it's going to be cold, turning colder each day. But thank goodness we don't have a big snowpack around keeping it very cold. So I'm going back to change a model. I wanted to give you an idea what ensembles mean. We have a global ensemble forecast spaghetti chart, and we're just going to look at North America. And I want to know what's going on with 500 millibar. I want to see how that low is being handled by all the models. So I'm just doing a 3-day forecast. And this is going to look wild with time. Notice how they kind of begin to diverge a little bit, especially out here. But through 72 hours, this is actually an extremely confident forecast. So say I wanted to go way out in the future here. And we'll show you how this can change, just to give you an idea that if I look way out, 240 hours, 10 days out, that look like anything you want to make a forecast from? So what that tells me is that the pattern is changing with time later in the forecast period. And the model does not have a good handle on it at all right now. So finally, we can go back and there's statistics I could show you that give you an actual temperature forecast. And we can actually look at them, national model blend of statistics. What they do is derive statistics where the model's wrong. They look at all the verification for the last several years and develop equations that take out bias from the model. So if I wanted to know what the 2-meter minimum temperature was going to be, and I want to know what it was going to be on 72 hours out, right there's my forecast. You can see that it's fairly cold, with temperatures generally probably 35 to 40 across much of West Virginia, maybe even 30 to 35 in the northern part of the state. So all of that, and then I can look at the Weather Prediction Center actually puts together forecast, and here is their forecast for days 1 through 3, 2.5. So if I'm interested in a Saturday forecast, notice this model still keeps that low there, but here comes another little cold front coming around that low and swinging through West Virginia Saturday morning. That's a reinforcing shot of cold air coming in, and probably with some light showers. So Saturday probably will be partly cloudy, little showers, maybe a few showers around, and maybe Saturday night there could be a few snowflakes. So this is how you apply everything you've learned into making a forecast out in the future. So be interesting. Give it a try yourself sometime. Everything I've talked about are from National Weather Service pages that are publicly available and that are part of the course I've given you. So let me know if you have any questions.